जी अस्सलाम वालेकुम class. My name is Engineer Hassan Raza and today we are going to start our lecture number 9, chapter number 4, and this chapter is all about structures, and the course outlines are chapter outlines are introduction of the chapter, plane trusses, method of joint, method of section, space trusses, frame and machines, and then numerical problems of the chapter as well. So before going for the chapter, so what is structure? Structure is a thing constructed by joining different parts together so that a single entity can be formed is known as structure. So structures has many types like trusses, frames, machine and many other parts as well. So basically in structure different parts are joined together to form a single entity. So as far as concerned there structure determinacy, there are two type of structure, statistically determinate and indeterminate structure, and in further detail we will discuss each. So basically structures follow the Newton's third law of motion, which is every action has a reaction equal in magnitude but opposite in direction. Here is a basic example of a structure, and in structure it's a further example of truss. सो इट्स ए ब्रिज एग्जाम्पल. आपने देखा होगा कि जो हमारे पुराने ब्रिजेस वगैरह हैं जस्ट सिमिलर टू दिस. सो बेसिकली देयर आर टू पार्ट्स. दिस वन इज़ द क्रॉस बीम एंड दिस वन इज़ द स्टिंगर. here are the example commonly used bridge trusses: Pratt, Hoy, Vaughan, Kay and Baltimore. These are the name of the scientists or you can say engineers that have designed these structures. So commonly used roof trusses जो कि हमारे roofs में in large sheds में workshop में use होते हैं. Fink, Pratt, Hoy and Vaughan. So what is truss? A framework composed of members joined at their ends to form a rigid structure is called a truss. Like bridges, roofs, forts, barracks and other structures are common example of trusses, in which I-beams, bars, channels, angles are joined to form a connection by using welding. Riveted or large bolts are used to connect these members together to form a truss. And if a truss lies in a single plane, then this truss is known as plane truss. So what is simple truss? A simple truss is those in which the members are joined in a triangular pattern like this one. So this one is a perfect example of plain simple truss. Plain truss means it lies in a simple plane, and simple truss means and the members are joined in the form of a triangular shape is known as simple truss. So simple truss is basically a rigid, or plain truss is a rigid structure. Rigid means they are non-collapsible and they have withstand deformation under the internal strain is very negligible. So there will, in case of rigid structure, there will be no deformation due to internal strains, and these are non-collapsible. Sometimes additional members are not necessary to maintain the equilibrium condition. These additional members are known as redundant members. When two forces are applied at the end of members and are necessarily equal, opposite and collinear for equilibrium condition. Basically in all these type of structure we are following the phenomena or parameters of equilibrium. Equilibrium means the summation of forces is equal to 0 and summation of movement is also equals to 0. Some of the members will be in the tension format or in the compression format, two forces meet. So basically these are the complete theory you have to study. So next one is truss connection and the supports. Trusses are joined to structure member. We may usually assume that the connection is a pin joint or a lever joint or can be a bearing joint as well. For large structure, a ruler, rocker or some kind of slip joint is used at one of support to provide for expansion or contraction due to temperature changes. So this one, A joint is the fixed joint, then B joint can be welded, riveted or bolted, likewise C, E, F. A, A is a pin joint, B, C, E and F can be riveted, bolted or welded joint, but D is a, in case of larger trusses there can be temperature expansion in summer season, and in winter season can be contraction due to temperature change and the impact of the temperature change on metal. So that's why ruler supports are used, so that it can be moved to some extent for construction, contraction or expansion. Two methods for the force analysis of simple trusses given. Each method will be explained by two simple phenomena. Then the method of joint. This method for finding the forces in the member of truss, the condition of equilibrium for forces acting, connecting pin of each joint. There can be compression and tension as well in the members. So basically for statistical determinant structure, summation of forces must also be equal to 0. It means summation of forces in y direction is equal to 0 and summation of forces in x direction must also be equal to 0. So here are the joints and we can form their free body diagram or structural diagram as AB, AF and resultant. And here are some examples how we can change a structure, a complete structure into a simple shape into its free body diagram, solve the numerical problems or real life problems. So what is internal and external redundancy? If the test as a whole statistically indeterminate, the extra supports constitute external redundancy, कि जो हमारे पास एक्स्ट्रा मेंबर होंगे स्ट्रक्चर में, ट्रस में, मोर देन इक्विलिब्रियम कॉन्फ़िगरेशन, उनको हम एक्सटर्नल रिडंडेंसी कहेंगे. मैं भी आपको ये कर देता हूँ हाईलाइट भी. And if there are less members, if a test has more internal members than the necessary to prevent collapse, when the test is removed from its supports, then the extra member is known as internal redundancy. So there are two types of redundancy, internal and external. If the member has more extra supports is known as external redundancy, and more internal support is known as internal redundancy. And for statistical determinant structure, it must follow this equation: m plus 3 is equal to 2j. M is number of members plus 3 is equal to 2 into j is number of joints. For example, if we are dealing with a triangular truss, simple truss, it means there are 3 members and there are 3 joints. M will be equal to 3, 3 plus 3 is equal to 6 is equal to 2 into j, number of joints in case of triangle, or 3, 2 into 3 is equal to 6, so it means 6 is equal to 6. And in case of triangle, there are 6 is equal to 6. In case of rectangle or square shape, 4 plus 3 is equal to 7, 2 into 4 is equal to 8. So there will be statistical indeterminate structure. If the structure or truss follows this equation, then the structure will be known as statistical determinate structure, and if there are more members, then this will be known as extra members, and if there are less members, then it also known as deficiency. So if the case is m plus 3 is equal to 2j, there are more members than independent equation. This truss is statistical indeterminate internally, and f m plus 3 is less than 2j, then there is deficiency of internal member, thus the truss is unstable, will collapse under load. In this case, there will be more external members, and in this case there will be deficiency in internal members. So there are special conditions as well. These are the conditions of different. So now we are going to solve our first numerical problem, sample 411. And the statement is given as compute the force in each member of the loaded cantilever truss by the method of joints. The truss with the 7 members is given A, B, C, D, E. E is a pin joint and a fixed joint at B point through cabled with the tension T, and here is a normal reaction at point E, Ex and Ey due to pin joint, and we have formulated a diagram. This one is the free body diagram, then diagram to solve the numerical. So first of all we have to find each point individually so that we can solve for other point as well. First of all we have to find the moment at point E, which is equal to 5 distance multiplied by tension minus this 20 multiplied by 5 minus 30 multiplied by 5 plus 1 10. So tension will be equal to 80 kilonewton. I am going to repeat, tension multiplied by 5, it's a clockwise movement, minus this one 30 into 10, 20 into 5 is anti-clockwise movement. So we can as T is equal to 80 kilonewton, then we have to calculate the direction Ex, summation of forces in X direction is equal to 0. 80 into cos 30 minus Ex, 80 is the tension, cos 30 minus Ex is equal to 69.3. Then summation of forces in Y direction is equal to 0. 80 into sin 30 plus Ey minus 20 minus 30 is equal to Ey is equal to 10 kilonewton. So likewise we have to solve the numerical for all other points as well, like point A, point B, C and D as well. Next we have to find reactions at point A, 0.866 AB. This number is AB. Summation of forces in y direction is equal to 0, minus 30 is downward force, AB is equal to 34.6. Likewise, summation of forces in AX, AC minus this member is equal to 34.6, and we have to take the horizontal component of this member, 0.5, AC is equal to 17.32 kilonewton in the compression. So you have to solve first and numerical of this exercise as I have provided you complete solution 2, 3, 4, 5. Up to first 10 numericals you have to solve your own. If there is any question or query, you can ask me. Thank you very much.